Hello YouTube. Today we are implementing LRU cache, least recently used cache. This is Leetcode 146. The idea is that we have something called a cache, which you can think of as simply something that stores key value pairs. So let's say we wanted to, we added to our cache, the following key value, or just any key value. We could have an underlying data structure called like a hash map, or dictionary, which pretty much everyone's familiar with. And then when we call .get on this cache, we obtain the value from the dictionary and we return it. So far we haven't added anything. We haven't done anything special. There are a few twists to this problem though. One is that if the key doesn't exist in the cache, you want to return -1. So for example, if the value does not exist, which in a hash map, the value will be undefined if the key does not exist, then we return -1. Otherwise, we just return the value. Okay, but let's get on the meat of the problem. The meat of the problem is something called a least recently used cache, meaning our little hash map right here has a limit to how many items it can store. And if we cross that limit, we need to delete some of the items. So we're going to have something called a capacity that we want to keep track of. And essentially, when adding an item, something like if adding new item and like size of map already equals capacity, delete an item, specifically the least recently used item. So the question is, how do you keep track of when an item was last used? Well, what we need to do is anytime we add an item, kind of mark that this item, this value was just now used. And whenever we get an item, we need to somehow mark that this key value was just now used. The question is, how do we do that? And how do we do that in constant time? And essentially the answer is a doubly linked list. So to develop the intuition of why we want to use a doubly linked list, let's just think about lists for a second. So, a regular linked list, you can have like items pointing to each other. So like A points to B, B points to C, etc. Let's add item D to the list. We're going to add it to the tail of our list such that C points to it. And we by virtue of the data structure of this list, as opposed to a map, which is orderless, this has an inherent order to the list. So if we were to traverse through the list from the head node to the tail node, from A to D, we would know that A was used last and D was most recently used because we just added D. And what we could do is say, hey, if we added B, if we just used B or C, like if we just retrieved B by getting it, or we updated the value of it through put, because we'll say that this like B is a key and that there's associated value pair with it. If we just used B in any way, we would put B to the tail of the list again. 1 second, we are going to get my chart.